Give us a break.
Don't try anything you're about to see us do at home.
On this trucking episode of MythBusters, we've got 3 big stories about big rigs.
That is crazy!
First up, there's the dynamometer of death.
This is the coolest toy ever!
Adam and Jamie test the gory story that a truck tire blowout can knock your block off.
Wow!
Then buckle up as the team takes on the Night Rider.
I just hope the car still works when I get my turn.
Adam and Jamie ask, can you ramp it up on the highway?
55.
And finally, Carrie, Tori, and Grant put their lives on the line
It's getting dangerous now, and that's how we like it.
as they find out if drafting increases your fuel efficiency.
Oh my God!
Who are the MythBusters? Adam Savage
Is everybody ready for diving?
and Jamie Heineman.
Gets me all worked up just looking at it.
This is beautiful!
Between them, more than 30 years of special effects experience.
That was heavy.
Joining them, Grant Imahara,
Jamie makes it look so easy when he does it.
Tori Belleci,
Somebody order some exploding pants?
and Carrie Byron.
High explosives and electricity. Woo!
They don't just tell the myths, they put them to the test.
We have a killer of a myth, literally.
Bring it on.
Well, you're in a vehicle alongside a semi-trailer truck, and the myth is that when the tire blows, it's such a powerful explosion that it'll not only break your windshield, but also decapitate you.
That is perfect and right up our alley.
Tires can sure turn nasty. Overpressurize them, and the results are explosive. But if you're unlucky enough to be alongside when a big rig tire blows, would you literally lose your head?
Dynamometer. Now, I was thinking this is a perfect thing for spinning our truck tire up to speed, except that nobody west of the Rockies is willing to let us blow a truck tire anywhere near their dynamometer. We're gonna have to make our own.
Why don't we do it MythBuster style? We'll, say, get a really powerful old pickup truck and yank the bed off of it and drive the pickup drive wheel up to speed just underneath the truck tire, and that'll take the truck tire up to speed, and we're there.
Let's do it.
In a typically ingenious plan of action, Adam and Jamie will build their own supersized dynamometer. They'll sink a pickup truck, lower a big rig onto the spinning wheels, and put Buster in the firing line.
In 3, 2, 1.
And the first step in taking Buster's block off with a blowout is paring back this pickup.
We cut the sides off this truck because we need to expose the drive wheel. The drive wheel is going to provide the power to turn the big semi-trailer tire. So we need to get at that wheel. We've got everything else out of the way. We'll put the semi-trailer on top of this and fire this puppy up and see what happens.
Jamie makes it all sound so easy, but at the Shobogun range, the reality is that this is an enormous undertaking.
Our trailer's gonna go here. Our pickup truck's gonna go there.
The pickup's drive wheels need to spin at more than 50 miles an hour. But so that it can't go anywhere, the MythBusters must sink its tires into the ground.
Dude, give it more gas! Well, hell, that ain't no truck no more. That's a dynamometer.
With the dyno fired up, next the boys need a big rig to put on it. And this should do.
Yeah! I've just secured our big rig trailer to the biggest forklift we've ever used on the show, which is rated to 30,000 pounds. It's not only a safety precaution, but it's also a key part of the experiment in allowing us to adjust how much pressure is actually on the big rig's tire.
With the forklift locked and loaded, the trailer is lowered into position. And once the two tires kiss, everything's ready for a test.
Look at that.
Their dynamometer may be ugly, but it works like a charm.
That's what you call the ghetto dynamometer.
So now, it's time to burn rubber and blow this big rig myth sky high.
Seems fine.
Yeah, I agree. We get it up to speed. Boom, do it.
The big rig myth that we get to test happens to be one of the most popular topics on the fan site. Have you guys heard of drafting?
Oh, that's when you try to get up as close as possible behind a trailer of a big rig to save fuel. Yeah, the idea is that the big rig slices through the air, creates a low pressure zone in its wake, and you need less fuel to move your car. Dude, I've always wanted to try it, but I just never had the nerve. I was afraid that the driver was going to slam on the brakes.
Following a big rig dangerously close may seem like an insane way to pass time, but according to fans, it can actually save you money. The theory is that the closer you tailgate a truck, the more you'll decrease the drag of air resistance, and the more fuel you'll save.
Before we go full size with this myth, I think we ought to do a few small scale tests just to see if there's anything going on behind the big rig aerodynamically.
If we're going to test aerodynamics, I know NASA has a wind tunnel. I'd be happy to go call them and see if they'll work with us.
In the past, the team have constructed their own wind tunnels for testing.
That's exactly what we're looking for.
But this time they're going straight to the big guns, NASA.
And the idea is that the wind flowing through here is very even and steady. We're going to blow smoke through over our model big rig, and if we see that smoke collecting at the back end, that indicates a low pressure zone.
With the high-speed camera primed to catch the action, it's all systems go for the smoke and wind. To the naked eye, it's hard to see a pattern, but things become crystal clear on the high speed. There's an obvious dead zone, a protected area where the oncoming smoke doesn't reach, protecting any following car from drag.
Smoke was gathering behind the truck, which proves to us that there is a low pressure area. What we're going to do now is take a car in the same scale as the truck, attach it to a force gauge, and then see what kind of effect that low pressure has on the car.
But just before that, the team first needs a baseline. So the truck is removed from the track to see what the force of the oncoming wind is like on the car alone. With the smoke off, it may look like nothing's happening, but the wind is roaring past the car at over 50 miles per hour. And Grant gets a reading.
Okay, so it looks like we got a good baseline. Definitely. 0.142 pounds. And that is just the wind on the car alone.
So that's the control. The question now is, will this figure reduce with a semi shielding the airstream?
We're now full 7 car lengths away. Do we have any drag whatsoever?
We have 21% drag reduction.
Are you serious?
Yeah.
Wow.
For Carrie, that was the wow factor. So how about when the car gets dangerously close? First, they wind the truck in to decrease the distance to 5 inches, or 10 feet if this were full scale.
All right, so we're at 10 feet. That's a 60% reduction in drag.
Whoa. That is insanity.
All right, we're at 6 feet away from the truck.
That is ridiculous.
I don't think I'd want to drive that close to the back of the truck.
Let me tell you, you might want to reconsider. 80% reduction in drag.
Dude, I'm definitely driving.
Let's go to the suicide zone.
All right, let's go to 2 feet. What are we reading?
You know what's crazy? We're reading 93% reduction in drag.
Are you serious?
Yeah.
It's an astounding result. But would this actually translate to fuel savings on the open road? Well, there's only one way to find out. The team will have to go full scale and test this myth for real.
This is great evidence for us to go on to the full-scale test.
Absolutely. We need a big rig. We need a car.
And we definitely need to investigate this further.
And we need a crazy driver. Who's that going to be?
Later.
Can we use this ramp to get into this big rig at highway speed?
But before all that, the boys bring out the big guns on Buster.
That's a hit, man. Nicely done. Welcome back. The myth we're testing is if you're driving alongside a big rig when its tire blows, can that exploding tire kill you or specifically behead you? So, this is our big rig suspended in midair by our 30,000-pound forklift. We are going to lower this down onto our dynamometer. I know it looks like a pickup truck, but in fact it's a dynamometer. It'll spin up to speed. Spinning this wheel in the correct direction, we are going to make this tire fail by hell or high water, and that failing tire hopefully will knock Buster's head right off his body.
The reason we're using a motorcycle here is because this is a worst-case scenario. Obviously, on a motorcycle, you're a lot more exposed. And so if a big tire like this goes off, well, we could have put a car there. We figured this is the nastiest thing we can do with this particular experiment.
Things are only going to get nastier for Buster, because to blow the tire, Adam and Jamie are going with the direct approach. That's the shotgun.
We're using a standard 12-gauge shotgun with a deer slug in it. The deer slug is actually one of the heavier bullets that is available in any kind of normal civilian weapon. It'll penetrate the tire, and the big question here is whether the air inside the tire is enough to actually make it rip or do something violent other than hiss.
And what we're hoping, if everything goes really well, what'll happen is that slug will enter the tire right about here and compromise the radial. That's the steel wires that run around the perimeter of the tire. Once that radial gets compromised, if the gods are shining on us, this thing will open up like a zipper and fail in a magnificent fashion, slicing Buster's head right off.
That's the theory, but in case the impact is not enough to sever Buster's head, the team has an injury monitoring backup.
Our crash test dummy has shock watch stickers, so by looking at which one of these gets tripped, both on his head and on his torso, we'll be able to see what kind of damage he sustains during this tire accident.
With the dynamometer spinning, it's time for the magic bullet. Of course, this isn't a typical way for a truck tire to blow, but this should result in the catastrophic failure that this myth needs.
Okay, This is tire blowout, shotgun shell, revving the engine. That's a hit, man. Nicely done. I heard it go up.
Yep.
But that was not the catastrophic failure we wanted.
Jamie was right on the money, hitting the tire dead on. But there sure was no explosion.
That's a neat hole. It's right there.
That's the hole?
Well, that ought to tell us something. I mean, that bullet's that big around. You know, they don't get any bigger than that, and it hit it clean right in the sidewall. It had to hit some of those cables. That was full pressure. It was a perfect hit, so.
The high speed shows the moment of impact as the slug pierces the tire. But Buster's white-knuckle ride is unaffected. To get a tire explosion, you're going to need a plan B.
We have to come up with a new plan, because what we're doing isn't working. These tires are super crazy, incredibly resilient.
Supposing you're silly enough to tailgate a truck, would this dangerous stunt really improve your gas mileage? Tori, Grant, and Carrie's wind tunnel tests have given this myth a thumbs up, in theory.
That is so much more than I expected.
But what about in practice? Time to go full scale.
We should drive at different distances behind the truck. We'll start at 100 feet and move our way up to 2 feet and see if we save fuel as we get closer to the truck.
2 feet seems really dangerous. Who's gonna drive?
I think Grant should do it, because he just had his middle name legally changed to Danger.
Grant Danger Imahara. I like the sound of that.
The MythBusters also like the look of the impressive beast they've lined up for their full-scale test. At the Portland, Oregon headquarters of one of America's leading rig makers, Freightliner.
We've got this new Cascadia Freightliner here. It took 2,500 hours to shape the aerodynamics of this truck to make it the most fuel-efficient truck in the world. It's a brand new truck, and we're anxious to get it out on the track again and help you with that myth.
Test engineer Matt Markstaller reckons drafting is suicidal, especially considering how many blind spots are on a big rig. But he's agreed to help out under controlled conditions, which include a thorough workout for Grant, under the tutelage of Hollywood stunt driver Mike Ryan.
We actually want to build all the way up to a 2-foot distance between us and the truck. How dangerous is something like that?
Definitely something you don't want to encourage people to do. I mean, I think the statistic is about 3/4 of all the truck accidents in the world that involve a car and a semi-truck that have a fatality were caused by the person driving the car. It's pretty scary.
What I'm going to do right now is put a line across the track. That's going to be their starting point. I'm going to drive down a quarter of a mile, put another mark. Then we're going to have a half a mile to see how much fuel is being used.
It's on this half mile of track that the team will measure Grant's fuel consumption. And that's test engineer Andrew Smith's department.
What we've got here is our data acquisition system, and we're hooked up to the fuel injection system. In fact, what we're doing is exactly the same as if we were physically measuring the fuel that's going to the engine. We're recording all of that, and we can compare when we're behind a big rig and when we're not.
Once the fuel gauge is in place, Grant will make several runs behind the rig at 55 miles an hour, working his way incrementally from 100 feet down to 2 feet. But first up, it's the baseline.
This will be our control test. I'm going to drive along. We're going to measure data for half a mile. And I'll see how much fuel I'm using with nothing in front of me.
With Andrew riding shotgun, Grant puts the pedal to the metal.
Okay, approaching drag strip. Holding at 55. Still holding at 55. Approaching the stop. That's it.
Andrew crunches the numbers, and it turns out that driving at 55 miles per hour on the test track gave a fuel consumption of 32 miles per gallon. Will drafting really cause an increase in MPG?
We're gonna do it at 100 feet, 50 feet, 20 feet, 10 feet, and 2 feet, which I consider somewhat suicidal if you were driving on the highway.
3, 2, 1, go.
Grant starts out at a distance of 100 feet behind the truck, but even this is considered outside the safety zone for most road authorities, who recommend at least 150 feet between vehicles traveling at 55 miles per hour.
Crossing the finish line now.
Okay, so that was a good run at 100 feet. Maintain a constant distance at 55 miles per hour.
And the result is pretty dramatic. With 100 feet between car and rig, fuel consumption improved by over 10%. Next, Grant gets back up to 55 miles an hour and closes the gap to 50 feet.
We're gonna hold this speed. You can collect your data now.
With this size gap, fuel consumption improved by 20% on the control. Grant moves in even closer to 20 feet. This is starting to get hairy.
Starting to approach that blind spot. I can't see him with you.
At 20 feet, the slipstreaming effect of tailing the truck has improved fuel efficiency by an amazing 27%. But what about tailgating a big rig at 10 feet?
It's getting dangerous now. And that's how we like it.
Later,
That is crazy!
Grant earns his stunt driver stripes the crazy way.
That was crazy.
But next,
We want to know if this tire will behead this biker when it blows up.
in the wrong hands, tires can be downright dangerous. But can they kill if they explode? Well, for Adam and Jamie, getting a tire to explode in the first place is proving somewhat troublesome.
But that was not the catastrophic failure we wanted.
So to try to turn a tire torpedo, the team is next going to replicate the last moments of a tire that's done way too many miles. And subjecting another tire to high heat and low pressure should do just that.
Yeah, we need to heat it up with the external heaters, and we need to really reduce the PSI so that we can get the tire flexing, because that adds heat as well.
Flexing is responsible for most blowouts on highway trucks. If air pressure is too low, the rubber wobbles or flexes, and this flexing can cause rapid, explosive disintegration.
We've got heaters posed on both sides of the tire, and the idea is to bring the overall tire temperature up as high as we can get it with them. We're going to start off slow, kind of like a chicken on a spit. We're going to try and roast the tire, and we'll be looking at this on the thermal imaging camera, and hopefully somewhere in there, with all that flexing and all that heat, we'll get a catastrophic failure.
Once the new tire is inflated to 30 psi, a quarter of its usual pressure, the dynamometer is ready to roll.
Well, we're rotating the tire under stress. It's been going for about 5 minutes and it's already at 150 degrees. That's the external outer temperature of the tire. We know that the tires start to attain their failure mode around 350 degrees. So that's where our butter zone is going to be in this, hopefully. We just got to see how long it takes to get there.
But unfortunately, even after 10 minutes, the butter zone has not been reached.
It's capped there. It's just sticking around 200.
Although heat failed to fire up the low-pressure tire, all is not lost because the MythBusters have another trick up their sleeves. Will suddenly over-pressurizing the tire result in the biker beheading thereafter?
In this line, it's 150 psi. When I hook it up, it's just going to pass that onto the tire, and if the tire is sufficiently weakened, it's going to blow. Exploding tire, hopefully. Final test. In 3, 2, 1. Come on, baby! Come on.
There we go. That was it.
That was it? It looks just like a zipper.
It, it opened up where you cut it.
But it didn't propagate.
No.
No.
It didn't really. That wasn't very satisfying.
That wasn't what we're looking for here.
This time the tire did fail, but it still didn't fail catastrophically. With this myth deflating fast, Adam has one final plan.
Well, we've seen the blowout. Let's put it under a little pressure on the bottom tire and spin it up to speed. See if we get some shrapnel out of it.
Adam reckons that if the burst tire spins long enough, something's got to give. And sure enough, as the dyno picks up speed, rubber shrapnel soon starts flying far and wide. But have any of these tire torpedoes toppled our Wild Hog Busters?
This is the coolest toy ever! Pull over!
Although rubber shrapnel did get flung, none of it hit our biker. So what does this mean for the myth?
If we look at the footage from that camera over there, you'll see one of the large chunks of rubber that flew about 200 feet in that direction.
I watched one piece go like maybe 70, 80 feet straight up. We need to actually find out what happens when you do get hit.
Yeah, we need to make it a non-random event. We need to make a rubber chucker. We need to make something that chucks chunks, large chunks of rubber right at Buster's head to see what kind of damage it'll do.
But before all that, it's time to get kitted out with another myth.
Okay, so what do we got now?
Well, I've got a big rig myth of my own. Have you ever seen the show from the early 80s called Knight Rider?
Yeah, wasn't the car intelligent or something?
It was. Do you remember how that car came in for repairs?
Yeah, he drove it right up into the back of a big rig.
At speed.
Yeah.
I want to know if that's really possible, or if when your 60-mile-an-hour drive wheel hits that ramp, boo, launches you right into the container.
Well, wear your seatbelt.
I will.
Before the Hoff was the Hoff, he was the Knight Rider. And his ride? Well, this four-wheeled black beauty was smarter than your average car. And if it needed running repairs, there was the famous high-speed entry into the team's mobile HQ. But in real life, once you hit the ramp, wouldn't you suddenly accelerate and catapult yourself through the cabin?
Obviously we're going to go full scale, but I think we ought to go small scale first. Let's get like an RC car and a running treadmill, and just do the whole experiment in miniature first.
Okay.
Yep, it's the patented MythBuster bench test. In this setup, Adam builds the scaled-down remote control car.
Yeah, look at that.
And Jamie vandalizes a treadmill to replicate the rolling surface of the highway. Ingenious.
The treadmill here represents the road surface. We have a miniature representation of a truck, we have a miniature car. So the main thing that we're looking for here is what happens when the car makes a transition fully from the road surface onto the truck. If it were to do something like a wheelie or just spin out of control, not get traction or something weird like that.
As JD said, the crucial moment is when the tires of the car get traction on the ramp. At that point, both vehicles are traveling at much the same velocity. But once it hits the ramp, the car is now moving at speed, and in comparison, the truck is stationary. And the theory is, without a special effects department, wouldn't that cause it to accelerate out of control? But that's just the theory. How about the practice?
Yeah. There you go.
No need for practice. In a break with MythBuster tradition, there was first-time success with a small-scale test.
We've been thinking that the moment those back wheels traveling at this speed hit this ramp, that car goes fa-ching.
The high-speed camera confirms there's no fa-ching factor. The RC car slid into the trailer as smooth as you like. And even without brakes, its entry was slow enough to prevent a serious fender bender with the back wall of the big rig.
So, I don't know about you, but the small-scale experiment really gave me a lot of confidence that this might actually be possible.
Yeah, and when you think about it, the car's got a lot of inertia, and for this to crash into the back of the semi, it'd have to all of a